Welcome to the latest video in IT Sec Hub. It's Nmap for beginners with Wireshark. So we will learn about Nmap and how to use Wireshark to analyze the Nmap packets. So stay tuned with me to the end of this video. So the agenda for today's session. First we will see what is Nmap. Then the Nmap command for ping scanning. I would say this is the most popular command in Nmap. Then the various commands for port scanning. Then how TCP scanning works, including TCP three-way handshake, and how Wireshark can be used to analyze packets, and commands for detecting operating systems and aggressive mode. So let's jump into the topic. What is Nmap? Nmap has an official website, that is nmap.org. From this website, you can get more details and learn about Nmap. Nmap is a free network scanner and a network mapper. This is a brilliant tool for network discovery and security audits. You can use this for finding vulnerabilities in your network and for hacking. But we are not encouraging any sort of hacking activity. But it is better you understand it to protect yourself from hacking. Content in this tutorial is for informational and educational purposes only, and for those who are willing and curious to know and learn about ethical hacking, security, and penetration testing. Anytime the word hacking that is used here shall be regarded as ethical hacking. Do not attempt to violate the law with anything contained here. If you plan to use the content for illegal purposes, then please leave this tutorial immediately. We will not be responsible for your any illegal action. So you can download Nmap from this website and install. If you are a Kali user, you probably have Nmap installed by default. So you go to terminal. And type nmap space -- version and see. So you have Nmap installed. The Nmap version is 7.92. Otherwise, you can install Nmap through the terminal. For CentOS and Red Hat distributions, you can install Nmap by sudo yum install nmap command. For Ubuntu and Debian distributions, you can install Nmap by sudo apt-get install nmap. Installing Nmap would be a very simple task, so I am not going to cover Nmap installation in detail. So I will move with the already installed Nmap tool for this demonstration. So we can right away start. Okay, let's see what our network is. The most popular command, ifconfig. So we are in 192.168.8.0 range. So we'll see who are the others in my network. So how to identify this? We will ping and see 192.168.8.1. Okay, it's there. We'll ping to 192.168.8.2. No, it's not there. So in my network, there can be hosts from 1 to 254. Am I going to ping one by one? Impossible. So there could be another way. How to identify this? So with Nmap, you have a command nmap -sp, and this command is called the ping scan. So this will give you a result with the IP address of all live hosts. So the network 192.168.8.0/24. This is the net mask. So you press enter and wait. Okay, found. Now this has scanned 256 IP addresses and found that 3 hosts are up and running. So the IP addresses of this is given. But this does not give much details. This only gives who are the hosts up and running. So we basically call this ping scan. This is the most popular command in Nmap. So instead of specifying the full network, you can specify an IP range. So you can type nmap 192.168.8.1 to 200. So this is the starting IP address and the ending IP address. So when you press enter, it will scan for the hosts that are in this range. So you can see the progress by just pressing spacebar. Okay, it's done. So with this scanning, by default, the Nmap scan for 1000 ports for each host. So for this IP address, it has scanned 1000 ports. So there's 997 closed ports and 3 open ports. So port 554, it's a TCP port, state is open and the service is for RTSP. Then port number 8000, that is also a TCP port, state is open, it's for HTTP alt. And 9010, it's a TCP and state is open and the service is SDR. So in the same way, it has scanned each and every IP address. So let's see how to scan for a specific port. So with Nmap, there's a command with the P switch. So we type Nmap -P, that is to specify the port. Then the port, we'll say port 80. Then the IP address. Sorry. So this will scan for port number 80 and it will give the status of that port. So if we want to scan for a range of ports or multiple ports, we can extend this command to nmap -p, then the ports, then the IP address. So this will give the status of each port that is specified in the command. So the port number 80 is open, the port 443 is open, and port 8000 is closed. So to specify a range of port, you can type from port number, we'll say 1 to 2000, then the IP address. So this time the command has scanned for the ports from 1 to 2000. Now we'll say we want to find only the open ports for the specific IP address. So there's a command. We type nmap -open, then the IP address to find the ports 192.168.8.1. So this will give the results by listing out the open ports. So these are the open ports for this particular IP address. So with port scanning, we can also specify the protocol type of the port. So we can type nmap -s. For TCP, we can type T. For UDP, we can type U. Now for TCP, we'll type T and -P, then the port 80, then the host. Port type is TCP. In the same way, we can specify the UDP ports as well. To scan UDP ports, you should have sudo privileges. So we'll type sudo, then nmap -s, then u for UDP port. We'll scan UDP port 53, then the host. Okay, the host is up. The 53 UDP port is closed. Okay. So with TCP scanning, we'll move into deep. So what is transport layer protocol? So with transport layer, it works with three-way handshake. Okay, this is TCP three-way handshake. The client sends a SYN flag to the server with the sequence number X. Then the server responds to the client with the acknowledgement number X plus 1. The server sends a SYN flag to the client as well with the sequence number Y. So the client responds back to the server for the sequence number Y. So the acknowledgement number for that is Y plus 1. So this is called the TCP three-way handshake. So here a full connection is established. Server knows the client wants to communicate with the server, and client knows that the server wants to communicate with him. So both knows that they want to communicate with each other. So they shake their hands. So this is called the TCP three-way handshake, and it's a full connection. So what if the client wants to hide some details of him from the server? In that case, we establish a half-open connection. So this is called the stealth scan or the SYN scan. Apart from that, there are some situations that the client wants to hide some details from the server. As an example, you can say a hacker. So a hacker doesn't want to expose their details to a server. So in such situations, the client sends a SYN flag to the server as a normal connection. So the server also thinks that this is a normal connection. As an example, we would say the client wants to check whether the port 22 is open at the server. So the server thinks this is a normal situation. So the server acknowledged to this SYN flag with the acknowledgement number X plus 1. That is, the server says that the port 22 is open. And server also send a SYN flag with the sequence number Y to the client, thinking that the client would respond to this. But what does client do? The client forcefully terminates this connection by sending the RST flag. That is, it says that, oh, just forget it. So we call this is a half-open connection. The client gets the details what he wants. That is, the client gets to know the port 22 is open at the server. So this half-open connection is called the stealth scan or the SYN scan. So what happens if the port is closed at the server? So in such situations, the server responds with the RST flag. So it says that the port is closed. So the client gets the details what it requires. So client knows that the port is closed. There are some situations a firewall is in front of the server. So even the client sends a SYN flag to the server does not respond. The client repeatedly sends the SYN flag to the server and waits for a response, and the client does not get it. So in such situation, client gets to know that the server has a firewall in front of it. So we will analyze TCP scan and SYN scan through Wireshark. Wireshark is a free and open source packet analyzer. So you can get more details about Wireshark from its official website. So this is the Wireshark official website. It's www.wireshark.org. So you can download Wireshark for your Windows or Linux machine, even for the Mac OS. So the best thing is you have pre-installed Wireshark in your Kali machine. So if you go to your Kali machine and search for Wireshark, here it is. You have Wireshark in your Kali machine. So this is the network interface in Wireshark. And this blue color button is to capture the packets through the selected interface. Here it is for the ETH0. So I have traffic going through ETH0 and ETH1. So if I press this blue color button, it will start to capture the packets through ETH0 since ETH0 is the selected interface. So here it captures the packets through ETH0. So I can stop capturing packets by pressing this red color stop button. Okay, now we'll try to analyze TCP scan and SYN scan packets through Wireshark. First we'll go to terminal and type nmap space dash s then p then space 192.168.8.0/24. So I am trying to identify a host in my network to do the TCP scan and the SYN scan. So we have 192.168.8.113 in our network. So now we'll go to Wireshark and enable capturing and then go to terminal and type nmap space dash s then t for TCP scan then the target 192.168.8.113. Now you can see in the background the TCP scan packets are being captured by Wireshark and the scan is over and we can stop capturing packets. And a good thing in Wireshark is you can do offline analysis. Now the Wireshark has given a number of records, so it's difficult to analyze. So Wireshark gives an option to filter the records. So our target is 192.168.8.113. So if we type ifconfig, we can see my address is 192.168.8.189. So we will type ip.addr equals 192.168.8.113, which is our target. So this will reduce the number of records. So we can expand this by combining another filter for the port. So the port given through the scan was we'll take 135. So we go to Wireshark. For the port, TCP dot port equals it's 135 and press enter. So this will give only a few records. So the source address is my address. It is 192.168.8.189. Then the target or the destination is 192.168.8.113. The protocol is TCP. And you can see a SYN flag is sent from the source to the destination, that is to 113. And accordingly, 113 responds with the acknowledgement and also sends a SYN flag to 189 expecting an acknowledgement. So 189 acknowledges with the AC key flag. So there's another duplicate acknowledgement, so we'll ignore that. And then 189 sends a reset flag to terminate the connection. That is, because with Nmap, you don't send data. If you take these three records, you can see the SYN flag, then the acknowledgement, and again a SYN flag, and the acknowledgement. So the TCP three-way handshake is completed. So if you go to the transmission control protocol, you can see the conversation completeness. The status of it is complete with no data. So that's why the RST flag is set here. If you send data, there could be some other flags. And if you move further down under the flags, for the first record, you can see the SYN is set. For this SYN, the SYN is set to 1. And for the second record, the acknowledgement is set to 1 and also the SYN is set to 1. And for the third record, the acknowledgement is set to 1. So this is how the TCP scan works. Now again we'll enable capturing packets and try to analyze how the SYN scan behaves. So we'll type nmap space dash s. Sorry, you need to have sudo privileges for this. Sudo nmap S, then capital S space the target 192.168.8.113. Then press enter. So it starts capturing packets. So the scan is over. Now we'll analyze for the same port number. Since the filter is there, you can see the records for the port 135. So the 189 sends a SYN flag to the target 113, treating as a normal connection. Server 113 acknowledges it and sends a SYN flag. Then 189 sends the reset flag. Now earlier we saw the acknowledgement from the 189, but here the acknowledgement is not there but a reset flag. So there is no three records for the conversation. If you go to the transmission control protocol and see the status of the conversation completeness, it says incomplete. You can move further down and under flags, you see the SYN is set to 1. For the second record, you see SYN is set to 1 as well as the acknowledgement is set to 1. Then for the third record, only the reset is set to 1. The acknowledgement is 0. So this is the half open connection. Even though the 113 is expecting acknowledgement from the 189, it did not receive the acknowledgement. Instead, it received the reset. So we'll try to figure out the other commands in Nmap. So we can stop capturing. So you go to Nmap. Okay, we'll close Wireshark for the moment. So our next command is to detect the operating system. So you need to have sudo privileges to run this command. So you type sudo nmap dash then O to capital O to detect the operating system, then the target. So it gives whole bunch of details with the port, the status of the port and the service. And here you can see the operating system of the target. Now the ports are being declared and the operating system is given. So this is something a hacker would need. Even though I use my personal network to scan, there's a host given by Nmap organization to test and learn. So this host is called scanme.nmap.org. So we can access this host and use it for testing and learning purposes. So you can type scanme.nmap.org. So we'll go to our terminal. So the command for the aggressive mode is nmap space dash capital A, then the target. The target would be scanme.nmap.org. So here with aggressive mode, this enables OS detection, version detection, script scanning, and the trace route. Okay, done. Now if you go to the result, so here it gives the port number, state, service, and version. The port 22 is a TCP port, and the state of the port is open, and the service is called SSH, and the version of the SSH is given. It's open SSH use 6.6, and all other details. And the SSH host key is given. And in the latter part, you will be given the operating system with the kernel. So this is a command that gives more details about the host. So with this command, we'll end up our session, and please stay tuned with IT Sec Hub for more videos. And if you have not subscribed to my channel, please subscribe.